All right, so we're going to start talking about what are called logarithmic functions. Now, you may remember these from your high school math class, and maybe you didn't like them, usually because your teacher didn't like them. So we're going to go a little bit more methodically through this and hopefully let you make friends with logarithmic functions, because if you're going to use any mathematics beyond college algebra, you're going to be seeing these guys again. So our objectives in this section are to get comfortable with converting between exponential equations and logarithmic equations, to learn how to evaluate logarithms without a calculator when possible, with a calculator when needed, to learn the difference between common and natural logarithms, and a little bit about the change of base formula. So we want to start off by thinking about just a plain old exponential function. So we don't even have an a on here. We've just got b to the x, which of course is really 1 times b to the x, right? And we want this to be a growth function, so we're going to specify that b is greater than 1. So if we think about what this graph would look like, we know it would have a y-intercept at 0, 1, right? And because b is greater than 1, we know that it is exponential growth, so it is increasing. So we would expect something like that, right? And we do know that this has an inverse because it is 1 to 1. And we also remember, hopefully, from when we talked about inverse functions, that the graph of the inverse function of the exponential will be a reflection across the 45-degree line. So there's my 45-degree line. And so we can kind of sketch in this reflection. We know if the exponential has the point 0, 1, so its inverse would have the point 1, 0. And instead of a horizontal asymptote, we would have a vertical asymptote. So we would kind of expect, of course, I didn't even draw my y-axis correctly, but whatever. So we'd expect something looking like this. So this will be our inverse of b to the x, right? And so the question is, well, how do we figure out what the equation of that inverse function is? Because remember, when we talked about inverse functions, the rules were swap x and y, solve for y, right? So, we're looking at, well, how do we solve an equation like 38 equals 5 to the x? How do we solve that for x? And this is where the logarithmic equation, or logarithmic function rather, comes into play. And so here we've got graphed the same graph. This is, I think, 2 to the x, yeah, because we have 0, 1, oops, and we have 1, 2, and 2, 4. So yes, it is 2 to the x. We know that this is a 1-to-1 function. And remember here that not only do I know from plug and chug, but we can say, ratios of y values. We can say 8 over 4 has a ratio of 2, 4 over 2 has a ratio of 2, and 2 over 1 has a ratio of 2. So remember, that's how we get that base, that b value, by taking the ratio of consecutive points, consecutive y values, for an exponential function. So we've got this f of x equals 2 to the x. We know it's 1 to 1. We know it has an inverse. So if we write this, we say, okay, I've got y equals 2 to the x. If I'm going to swap my x's and my y's, then I would have x equals 2 to the y, right? And how do we solve for y? That's the question here. So, but let's think about a particular point first. So we could say, for instance, 2 to the y equals, let's say, 16, right? That would be like saying here, well, that's plugging in, right? Wait a second, maybe I should stick an x here first, right? 2 to the y equals 16. And we say, okay, what value of the variable here, I'm going to keep it y because we're trying to go for the inverse, right? We can look at this and we can say, oh, 2 to the y equals 16. Well, y has got to be, let's see, 2, 4, 8, 16. That is 2 to the 4th. So 2 to the 4 is going to be 16. So we can think about our inverse function, right? So our inverse function, we've got to solve this x equals 2 to the y for y. And none of our algebra tools do this for us, right? So someone somewhere along the way said, well, we need this inverse function for the exponential. I'm going to define a function called a logarithm. And so we're defining here basically that our inverse function, f inverse of x, is what's called log base 2 of x. So this answers the question, what power do I need to raise 2 to in order to get x? All right, so on our original function, we had the points 1, 2, 2, 4, 3, 8. And on our inverse function, this is f inverse, we're going to swap those x's and y's. And so this is, what power do I have to raise 2 to? This is going to be our base. More on this shortly. To get 2, right? 2 to the what? So we would say 2 to the 1, right? Log base 2 of 4. What power do I have to raise 2 to get 4? Question mark. I have to raise it to the 2 power. And log base 2 of 8 equals 2 to the what? I have to raise 2 to the 3rd power to get 8. Okay, so we're going to break here and then start and then talk about more about the basic logarithm function.